Now, as we look at example 6 here, I do want to point out that there's not always a unique answer to each of these problems. So we can actually come up with multiple answers to this particular problem. And I'm going to actually walk you through a couple of those. So we're looking for f of x and g of x so that f is the main thing going on, and g is going to be what is plugged in. Or you can look at it as what did I cover up with my thumb. So if I cover up a portion of this with my thumb, I could cover up the 2x plus 3, for instance. So that's my g of x, is the 2x plus 3. So what's left when I cover that up? Something cubed plus 5. And so if I'm doing f of x, that would be x cubed plus 5. So that's one way that I could actually solve this particular problem, and those are valid components to that composition, and that would work. But then I could go kind of either direction with this. I could say, well, what if I didn't quite cover up as much? What if I just covered up the 2x? And then I said, well, what's left when I do that? Something plus 3 cubed plus 5. So that would be x plus 3 cubed plus 5. That works too. That's a correct answer. And I could go the other direction too and say, what if, instead of covering up 2x plus 3 like I did originally, what if I covered up a little bit more? What if I covered up the 2x plus 3 cubed? So 2x plus 3 cubed is what I covered up. What's left when I do that? Something plus 5. So x plus 5. Each of these 3 different columns I have are valid answers to this problem that says find the components f and g so that my original problem can be written as f of g of x. Now this is important because there's different reasons, different purposes for what we're doing here. One is, of course, just the simple problem solving to say, all right, what are the steps? What are the pieces that make up the whole, which is a good problem solving technique. Now, also later on, if you go on to calculus, there's times where you want to do some calculus operations. Won't get into the specifics of what they're called. You know how to do it with an easy looking problem, but as they get more complicated, you don't know how to do it. So if you can break it up into 2 easier looking problems, like what we have here, then maybe it's going to be easier to solve the calculus problem. And that's what we end up using this for later on in math. We break up complicated problems into its pieces, into simpler parts.